Are you, everyone? Whether the PPT is visible, guys?
Visible, sir.
Yes, sir. Visible.
Okay. So next type of a transistor. So previously, so we've seen bipolar junction transistor. So bipolar representing the both the majority and minority charge carriers can able to do the conduction. So that's why they representing bipolar junction transistor. And I and another type of transistor is a Jfet. It is junction field effect transistor. So this is also one of the transistor which consists of three layers with three terminals and having two junctions. Okay, so let's see first the difference between the JFET and BJT. Okay, so this is a BJT. So BJT we may have a three terminal. One is a base, another is collector, and third one is emitter. The third one is emitter here, and this device is called as current control device. So why? Because based upon the base current, it is not about the base voltage, how much current is flowing through the base. So based upon that, the collector current will flow from here to down to the emitter. Okay, so this is called as current control device. So input current will control the output current. How much input current I am giving, that much output current will flow. So if I reduce the base current, the flow of current from collector to emitter will be reduced. If I increase the base current, and the collector to emitter current will increase. So that's why it is named as the current control device. And if you see FET, so field effect junction transistor, so FET is a voltage control device. So here we having a three terminal. This is a drain, and this is your gate, and the final this is your source. Okay, so keep on remember the pin name. So FET having a three terminal devices, and it is named as the one of the terminal is drain, and second one is gate. So gate is common in SCR also. We found a gate in SCR as well as the triac. We seen the gate. You know what is the purpose of gate terminal, and the another terminal is source. Okay. So here also the source will give the charges and charge carriers, and the drain will take up the charge carriers. So that's why it is named as a source. So it's a source for all the charge carriers, and as well as drain representing it will take away. It is a take away all the charge carriers. So that's why it is named as a drain. And the gate is used to control the flow of electrons which is flowing from source to gate. Okay, so if electron is moving source to drain, sorry, source to drain, as well as the current will be in opposite direction. So I am representing the current flow from drain to source. Okay, so here also there will be two types. One is in BJT, how we seen the NPN transistor and PNP transistor. In FET also we having a two types, P channel and N channel field effect transistor. Okay, so here is the family of the FET. So FET having a two family. One is the JFET, junction field effect transistor, and another is MOSFET, metal oxide semiconductor field effect transistor. So now we will concentrate on JFET. So JFET having a two types. One is the N channel and second is P channel. Let's see what is the N channel and P channel. So just an introduction about the advantages of the FET over BJT. So FET is a a BJT is a current control device, and FET is voltage control device. And FET having high input impedance. So what is the advantage of having a high input impedance means for an amplifier, the input should be very less, the output delivered should be very high. Okay, so in order to take the input very less amount of input, I required high input impedance. So then only it will gather less power, so that it will amplify the signal. After that it will produce the high power to the output. So that is a normal function of your amplifier, right? If an amplifier input itself much more and output also similar, means it is not amplifying anything. Okay, so that's why. So the advantages, every amplifier, the input should be very high when compared to the output. Okay, so here the input will be in terms of meha ohm, and it will be mostly used for linear, the AC amplifier circuits, alternating current. So alternating current means a voice and all. It's not only a DC, it's a AC. It's having the frequency. The oscillation will be there from positive to negative. Okay, and temperature stable than BJT. So in a BJT, you know the temperature effect, already we studied in PN junction diode. If there is a change in temperature, surely there will be change in the current as well as the voltage. But in a FET, it is not affecting. So FET cannot able to affect based upon the temperatures. That is one of the second advantage. And next in size, so BJT is much bigger when compared to the FET. Okay, so FET is very smaller when compared to the BJT. So that is another advantage. So that you can able to fabricate a small device. So you can able to observe that in olden days the mobile phones are very bigger. Why? Because the transistor size is very high, and nowadays the transistor size become reducing. So based upon the size of the transistor, the mobile phones also become slim nowadays. Okay. Next, the fabrication process. So FET fabrication process is very simple when compared to the BJT. So that is one of the advantages, great advantages. Instead of going for complex fabrication, fabrication means manufacturing. So I am manufacturing the FET. So that process is simple when compared to your BJT. Okay, and here they given the difference. So BJT conduction both holes and electrons, and the FET is unipolar. So BJT is bipolar, means FET is unipolar. So only one type of current carriers will be there. So only if it is electrons, means only electrons will use to flow. Holes means holes only used to flow. But in BJT, the electrons allows the holes also used to do the conduction. So that way you can able to see there will be a leakage current, so due to the magnetic charge carriers. So electrons is majority, means surely the minority will be a holes. So that's why it is named as the bipolar. And here FET is only one, so there is no magnetic charge carriers and all. And next is less noise compared to the BJT. BJT produce a lot of noise when compared to the FET, so that is another advantages. And so application is usually used as an amplifier and logic switch. So amplifier, you know, and what is a logic switch? So logic switch representing the switching the ones and zeros. So binary value is only, right, in digital world, everything is nothing but ones and zeros. So in order to change 1 to 0, 0 to 1, I will use the field effect transistor. So next disadvantage, if you see, so it is easily damageable when compared to the BJT. So BJT can able to deliver more amount of current. It can able to withstand, but FET cannot able to withstand. So it may damage easily when compared to the BJT. Okay, so BJT will preferable for some other application where high power will be there, and where more current has to drawn. So that capacity is BJT is available, but FET cannot able to provide a high power delivery. Okay, so why? Because it's a voltage control device, only voltage, and the current cannot be much more when compared to the BJT. Okay, so but BJT current flow will be high when compared to your FET. So that is one of the advantage for BJT. That's why still we are using BJT in some other application where high current is required. And here the types of the Jfet. So one is the N channel Jfet and P channel Jfet. Two types are there. Let's see the construction so that you can able to know what is the N channel and what is the P channel. And it consists of three terminals. One is a drain, and another is a gate, and the third one is your source. So drain, why it is named, in the sense it will drain all the charge carriers which is coming from the source, and source is used to provide the charge carriers, and gate is used to control. Okay, so here you can able to see the symbol, and this is your N channel JFET, and this is your P channel JFET. So how to identify the N channel and P channel means based upon the arrow mark. If you look at here, The arrow mark is the gate is having a arrow marks towards the drain, and if you look at this, the gate having the arrow mark outside. Okay, so that is a difference. You can able to identify whether it is a N channel or P channel. Say N channel means it is towards. I mean the arrow mark is towards the transistor. It is coming out of the transistor. Like in a BJT, so like in a BJT, how it will be. So if it is direction outside means it is a NPN, and if the direction is towards inverse means it is a PNP. So similarly here, so it is towards the transistor, here it is N channel, and it is away to the transistor, it is P channel, Jfet. And so here the channel representing the main material. So maximum percentage, majority of the structures will be covered by N type, in the sense that representing N channel JFET. And a small amount of P type will be embedded to form two junctions. So two junction, let me show. Yeah. So this is the construction. So if you look at this, the majority portion, the maximum portion is nothing but N channel. Only the few portion which is available inside of the N channel, so that is your a small amount of P type is fabricated inside in order to provide two junctions. So this is one of the junction, and this is the second junction. Okay, so usually what it will do, so here the channel representing here N channel representing the major structure which is available by N type. So if it is major structure available by P type, and either side it will be a N type, means that is your P channel. Okay, so here it is N channel, and in N channel JFET, the current flow will be from drain to source. So here I am representing using the arrow mark. The current flow will come from the drain towards your source, and it will be controlled by your gate. So that if for example here let me do here. So here I am giving the positive, here I am giving the negative on the time. This is the N type. So N type having a majority of electrons or holes.
Electrons.
So electrons will be there. Okay, here I am giving positive, here it is negative. So what it will do, where the electrons will go, whether the electrons will go to drain or electrons will go to source.
Source.
Source. Electron is positive charge or negative charge?
Negative.
Negative charge. So electron is negative. Source I am giving negative. What it will do? It will attract or it will repel?
Ripples.
Ripples. So it will ripple. The source will ripple. So and as well as if you see the drain is connected to positive, it will attract the electron. So based upon that, the electrons will, I mean the charge carriers will flow from here to there. Okay, so that is a basic operation, and I will explain the operation in detail first. Okay, let's first go to that structure, how it they are forming. So, so in a normal operation, so usually the drain will be always positive with respect to the source, and the drain current, it will flow into the drain and through the channels and out of the source, so that the electron will come from source to drain, and the current will flow from drain to source. That was mentioning here. See, look at this statement: current flows into the drain through the channel and out of the source. So here they are representing current will flow into the drain and through the channel. So this is through the channel and to the source. So this is the current direction. That is what representing here. And because the resistance of the channel depends on the gate to source voltage, and the drain current ID is controlled by the voltage. Actually, if you look at this here, the P, suppose for example gate I am giving 0, okay, and drain I am giving positive, and source I am giving negative. And if you look at this, in this layer it will be a forward bias or reverse bias. N I am giving positive, gate is grounded, so N I am giving a positive here, so it will be forward bias or reverse bias. It is forward or reverse. N is negative. sorry, n is positive, sorry, drain is connected to positive, so n is
Forward
positive.
bias.
N is positive, ma. N is positive. In a PN junction, forward bias means P I will connect to positive, N I will connect to negative. But here N is positive. Here in drain, I am connecting to positive, so N is connected to positive. It will be in reverse bias condition. So surely the depletion layer will keep on increase here, here and here. So let me show in operation. First we will see the channel, P channel. So in a P channel, similar to the N, here the majority structure is P type material and N type is embedded inside of your P type channel, so that you can able to form a two junction. Okay, and here the current will flow from source to drain, so quite opposite to your n channel, and here the majority are holes only, so conduction will be occur due to the holes which is injected into the source and through the p channel and flow to the drain. Okay, so this is source and this is drain. So how the electron is flowing, I mean the current is occurring here, it is quite opposite. Everything will be done by the holes and the direction will be quite opposite to your n channel. Okay. So this is the structure of your p channel Jfet. The current flow is occurring from a source to the drain, and here majority of the holes will be there. So here if the source is negative and the drain is positive, so hole will be moved from where to where? Hole be moved from, whether it will go towards
Past
the drain or it goes towards the
drain.
source. Drain, is it drain? Holes is positive charge, drain is positive charge. Holes will move
Sir,
from drain to
holds
source. Force
source.
will move from drain to source and the current will be moved from the source to drain. Okay, and this is just the example how they are giving the sense. This is a source, this is having huge charge carriers, and this is your drain. Source will give, I mean like they compared with the tap mechanism. So what is the source, what is the drain, and what is the gate? So if a gate is controlled, in the sense like there is no flow and all. Okay, even though source having a huge number of, I mean water content, if source having a water content, in technical form is source having a charge carriers, if gate is closed, in the sense nothing will be there. Okay, so drain cannot get any water. So if the gate is open, in the sense the source will keep on give the water and drain will take the water. So water representing the charge carriers. Okay, so this is just an example how the terminals are working. Okay, so you will see the operation here. So there will be three types of operation. One is if I kept VGS equal to 0 and drain to source voltage, I am increasing positive. That is the first basic operation. Let me see. And next second operation is the gate to source, I am giving more negative. Then I am keeping some positive value to the drain to source, and then I will check what is happening. And third one is voltage control resistor. Okay, so first we will see the first one using the animation. Listen here carefully. So here you have to see the three values. Okay, so this is your drain. Can you able to see my pointer, guys?
Yes, sir.
Yeah, so drain I am giving here, it is a source, and the side of your 2 is nothing but your gate. Okay, so gate is connected to one of the voltage, that is called gate to source voltage, VGS. So this is VGS. I will write it VGS. So this is your VGS, and here the drain to source voltage, so I am writing it VDS. So this is your drain to source voltage, which is connected across voltage are connected across drain with respect to the source. Okay, and if you look at this here, I'm going to increase the drain to source voltage 0 to 10. So this is one you have to observe, and again you have to observe whether what is the VGS voltage. Here for a N channel, the VGS should give negative. Okay, and initially I kept 0. Let's see why I am giving negative. Okay, and the third one is here, they are showing the characteristics. Okay, you have to observe. The first one is this one. What is the voltage drain to source voltage I am giving, and what is the gate to source voltage I am giving, and observe what is your conduction is occurring or not here, and as well as you have to look at the graph. So these all parameters you have to look, then then only you can able to understand. So how much VDS I am giving, what is the VGS I am giving, how the electrons is flowing, and what is the characteristics occurring. Is that clear? So I will play one by one and slowly. I will mute it. So look at this. Slowly first I am increasing the drain to source voltage. So once I start to increase, so now I kept 1 voltage. Can you able to see? I kept 1 voltage here. So the drain became more positive when compared to your source. So what it will happen, the charges which is occurring, that will emit. The electron will emit the charges, and the drain will take up the charges. So current flow will occur from drain to source in opposite direction. And if you look at this graph, it is representing 0 to 1 I am giving, and VGS equal to 0. Okay, so that you may get VGS equal to 0 at this level. I am keeping VGS equal to 0 at this level. So if your VGS is greater, I am getting more amount of current. If I increase 0 to 2, on the time this graph will move from 0 to 2. So on that time you get the maximum of your current. So this is nothing but ohmic region, and this the straight line representing the saturation region. Later we will discuss about this in deep. Now just observe that here the dotted line is the red green line that representing the amount of VDS, while I am changing how much current is flowing, that is represented using this blue lines. Okay, and this level is VGS equal to 0. So that is what representing here. So slowly if you keep on increasing VDS, automatically if you keep on increasing the VDS, automatically you can able to observe that this line will keep on increase. So that voltage is represented using the dotted line. Let's see, I will play this. So slowly I am increasing to 2. You can able to observe it is increasing. So speed of electron is also increasing, and once I reached let me stop. So once I reached 5 volt, I am porting out the 5 volt. At 5 volt, I am getting the maximum of approximately 18 milliamps. Okay, so it is available in between the 15 to, it is available in between your 15 to 20. So 18 milliamps I am getting. So initially I kept 0, there is no current, and slowly I am increasing 1. I got the voltage of around 5, and slowly I am increasing 2. I got about 10, and I'm increasing to 3. So that is your pinch of voltage VP. At the time I got the maximum charge carriers. Okay, once it is crossing the pinch off, it becomes saturated. Why? Because if you observe here, can you able to see there's a white area? Can you able to see the
Yes,
white
sir.
area? That is called your depletion region. If you keep on increasing drain current, this depletion region will increase. Why? Because this N is positive and P I connected to the ground, so surely it will act as a reverse bias condition. So depletion level will keep on increase. Initially, if you look at here, so you look at this position, is there any white area is increased? No. On why? Because the voltage which is given to the drain is very less, so depletion layer is less. So slowly if I am increasing, you can able to observe that the white area become increasing. Can you able to observe? So there is a change in the white area. It representing it is controlling due to increasing depletion region. The flow of electrons become stable. So that's why here they are representing the saturation region. So up to this it is pinch off, and after that it become reduced, so narrow. The path which is flowing, the electron is flowing from source to drain, it becomes very lesser. Okay, so it's making a constant current flow only. After it don't exit until this, I mean until it is crossing the pinch off, it is called a ohmic. Ohmic means there is a change in the resistance. So that's why it is, I mean current flow is also changing. Once it become constant, the current flow is become constant, so that the resistance is not changing. Due to this, depletion layer is occurring. Okay, so that the constant region from here to here, the straight line is there, right? So that is called your saturation region. Okay, so far VGS is 0. All of you clear about this? Everyone, guys?
Yes, sir. Understood.
So thing is, VDS I'm increasing from 0 to maximum, and so far I kept a gate equal to 0. So I got a waveform like slowly it is increasing by increasing the drain voltage, and this is your pinch off voltage representing. After that, the current won't doesn't vary, so it becomes constant. After you increasing the voltage, increasing the voltage of a drain, it becomes constant. And as well as, if you can observe here, there will be a change. So under less voltage, the depletion layer is very less. If you increasing the voltage, the depletion layer become higher, and the path which is flowing from source to drain become narrow. So narrow means it is reducing. Okay, next you are going to observe what will happen then if I am changing the gate to source voltage. Okay, and now I am going to change the gate voltage. Listen here, initially gate is 0. On the time you can observe that blue line is at top. So next, if I kept a gate voltage constant like 0.5, you can able to observe there will be a change in the voltage. Can you able to observe this? Look at the graph. I am changing the gate voltage 0 to minus 0.5. On the time, the amount of current is reduced to maximum. Sorry, amount of current is reduced to maximum of 15. If I kept gate as 0, the maximum amount of current is about 18. So if I kept gate is equal to minus 0.5, the amount is, I mean amount of current flow is become decreased to 15. So previously it is 18, now it is decreased to 15. Can you able to observe this, guys? You know what is the reason? Can anyone tell what is the reason? I am giving gate negative and the current flow is decreasing. Can anyone explain why? If I give a gate voltage to negative, the current flow is reducing. If I kept at minus 1, I am getting the maximum current of 13 milliamps. And again, if I kept the current to minus 1.5, I got the maximum current of 10. If I kept minus 2, I am getting maximum current of around 6. And if I kept minus 2.5, the maximum amount of current is 5. And look at this Jfet channel. What happened? I kept minus 2.5. What happened to that channel, ma? Are there any path is there to make a current flow? I mean, make electrons. Is the path is there, or it is blocked?
Blocked, sir.
So it is blocked. Why it is blocked?
The flow of electron is decreased, sir.
Flow of electron is decreased because of blocking. But I am asking, what is the reason of blocking? Why it is blocked? Why in the
Increasing
sense?
the
Hmm.
increase the value of gate, sir.
So if I am increasing the sense, I am making a device to work under reverse bias condition. Okay, look at this. The gate is P. The gate is P, right? P channel. The drain is N channel. N I am giving positive and gate I am giving negative. So it representing a more reverse bias condition. So due to more reverse bias condition, the depletion layer become increasing. So look at the graph. I mean, look at the I will show the animation. So look at this. Previously, the gate is 0. On the time the white area, reverse bias condition, depletion layer is less. Once I'm keep on increasing the gate towards negative. So from 0 to minus 2.5, I'm increasing. So you can able to observe that there will be a chances of increasing the depletion layer due to the reverse bias condition. So if you give a gate voltage towards negative, I can able to control the current flow. If I give a gate voltage towards positive, I can able to make a current flow. So thing is, for an n channel transistor, if a gate is positive means a more current will flow. If gate is negative means the current amount of current flowing is become reduced. Okay. Now observe the characteristics. So I kept a gate at in between -1 to minus 0.5. So on the time I may get the graph like this. So initially gate drain is 0 means 0. I'm increasing drain to 1. On the time I got the value of around 6, and after I reach the pinch of voltage I got the value of maximum 13. Okay. After that it is maintaining that 13 itself. If I change the gate, if I change the gate to -1 -2, on the time the maximum, if drain is changing from 0, it is 0. If drain is equal to Vp, I got the maximum value of your 6, and after that it becomes constant for phi itself. So this characteristics is for VGS is equal to -2, and this one, this characteristics is for VG is equal to -2, and this the topmost one is for VG is equal to 0. Okay, so it is for 0, and this is for 0 -0.5, and this characteristics for -1 and -1.5 at 2 -2.5. Okay, when you got the 0 current, that is called a cutoff region. Okay, so there is no conduction and all occurring. So if you increase the gate voltage to -2.5, the conduction is nothing will occur. So that area is representing your cutoff region. So Jfet cannot able to make a conduction. Okay. So again I kept a constant. Look at this. I kept gate as -2 constant. I got this graph, and now I'm going to vary the VDS. So VDS, how much that will be shown in using the green line, which is available in your characteristics. Look at the green line right now in the field. I'm going to change. So to maximum 10, I got maximum 10 voltage. That green line is moved to 10 voltage. After that, I will start to decrease. Sorry. Yeah. So now I kept phi. On the time what will be your current. So they are observing the characteristics by changing, keeping the gate to source as -2 voltage, and they are changing the VDS to 5 to 10. So that's what they are representing. How much current will be flow through the drain to source. Okay. After that, again I am just changing the gate voltage towards -1 so that the current will become increasing, and still it is I'm reducing the gate voltage so that the current is maximum. Well, if you understood the operation, so this is a difficult one to observe that 4 or 3 characteristics. I mean 4 or 3 ones. So first one is you have to observe about the VDS how much, and second is about VGS you have to observe, and you have to observe that the depletion layer whether increasing or decreasing, and you have to observe the characteristics. Is that clear, or I want to explain again the Jfet operation? Guys, is that clear?
Yes, sir.
Okay. So I will tell simply Jfet operation again. So here I am going to give drain as positive with respect to the source, and gate initially I kept at 0. get at 0. If I give a drain to 0, no current flow is there. If I give the slowly increasing the drain voltage with respect to the source, the current, I mean electron will start to flow in this direction. So electron will start to flow in this direction from source to drain. So the current flow will occur from drain to source. Okay. If I keep on increasing up to 10 voltage, what is happening? The N, so drain is N, right? This is N channel, and the gate is 0. So that the depletion layer will become increasing. So that's why I'm getting the after a pinch of voltage. So pinch off means where the current become stable. So there is no variation. From 0 to pinch of voltage, there will be a change in the current. After the pinch of voltage, the voltage become constant. Okay, so up to that, there will be a change in the current flow, representing change in resistance. So that area, so this area is representing the ohmic region. Okay, and after it is crossing the pinch off, the current becomes constant. It represented that particular amount of your area is occupied by your the depletion layer. Okay, so that's why it is allowing only a constant charge carriers. Why? Because if gate is, for example, if a gate is space is allowable for only one person, means only one person can go. If it is a maximum, means based upon the crowd how much I'm getting. Suppose 10 people going, means 10 people will go, 20 means 20, 1 means 1. So how much I am allowing, so that much the passenger, I mean the person will move from here to there crossing the gate. Okay, once it become narrow, so there will be a path for only one person, means only one person has to go. So for 1 second one person, means for 2 seconds 2%, it will become constant. So similarly here also, until this the gate is wider, I mean the channel is having sufficient space to make the charges carriers to grow. So based upon the input voltage, so the current will become vary. If less voltage, less current; more voltage, more current. Okay. Once it becomes a constant path, the channel is restricted due to the depletion layer. So only the particular, the constant carrier will be flow. So there won't be any changes. So that's why after that it become a constant. Understood about this saturation region? Why it is become saturation? Guys, so that's why it's become saturated. Okay, and afterwards I'm going to keep VDS. I'm going to change the VGS. So VGS is 0, means the current flow is increasing. Okay, and if I increase the VGS to negative minus 0.5, and I'm making the this junction towards reverse bias condition. So due to reverse bias condition, the depletion layer become increasing, so that the maximum amount of current will be controlled. If I kept at minus 1.5, the depletion layer become very high. Okay, so on the time, if you observe, the current, the maximum current will become very less. So for example 10, if I kept minus 2.5, the output current will be a 5 or 6. It will become keep on reducing. If I still increasing to minus 3, minus 4, and there is won't be any current flow, it will become a cutoff. So there is no any current flow will occur. It representing there is no any flow of charge carriers from source to drain. Okay, so this is the basic operations of your Jfet. Okay, initially here we represented two. One is for VGS equal to gate to source is 0, and afterwards I am changing the gate to source. So based upon the changing in gate to source, I am observing the operation. Is that clear, all of you? So
Yes, sir.
yeah, let me play once again. Just you just observe. I won't talk anything. You just observe that the animation. So the characteristics they given the same thing. So first one is about BGS equal to 0, and I'm changing the BDS. Okay, so what is happening? They given in terms of order. So I will just go through it, because already I explained. Just I will study. So to start, suppose BGS equal to 0, that when BDS is increased, so ID will increase. So therefore ID is directly proportional to your BDS. So the drain current is directly proportional to your drain to source voltage. Okay, and for large value of VDS, as VDS increases, the depletion layer become wider, so causing the resistance of the channel increase. Okay, so due to that only the current is become constant. After that there won't be any increasing, it will become a straight line. Okay, so after the pinch of voltage that VP is reached, the ID become nearly constant, so it is representing that ID maximum. So drain to source current with gate shorted, so shorted representing it is grounded. Okay. And now you know whether any gate current is making the role, or gate voltage is making the role here. Is it about the voltage or a current, guys? Is it about, I mean, the controlling the current is based upon the gate voltage or gate current? Listen, in a BJT, so based upon the base current, how much base current is flowing, that will initiate the current from collector to emitter. Okay, if base is 0, collector to emitter current is 0. If base current is 10 milliamps, collector to emitter current will be 100 milliamps. So based upon the current only, that's why the BJT is named as current control devices. If you look at here, uh, the current flowing from drain to source, that will be controlled by how much gate voltage I am giving. Why? Because here I am making the reverse bias condition, and I am blocking the conduction channel. Okay, so here it representing the voltage. So voltage is the only thing which I am giving to the gate to control the flow of current. So that's why the FET is named as voltage control device, and BJT is named as current control device. So here they are representing the same. Gate is grounded, so VGS equal to 0, VGS equal to 0, and drain I am giving positive with respect to your source. So this is a variable. So while I am increasing, you can able to observe that the depletion layer become very higher nearby the drain when compared to the source. Why? Because source is grounded, gate also grounded, so nothing will affect here. Only thing is the drain is more positive. I mean N channel become positive here. P is grounded, so depletion layer will increase in this area maximum. Okay. And so pinch off, so it's become, I mean narrow, it become narrow, so very limited number of electrons will flow. So once you increase the drain to maximum voltage, so this is how the uh, depletion layer will increase, and it will make a narrow path, so that the limited number of electrons will flow. That's why it's become a constant. Okay, so the characteristics they are drawing at VG is equal to 0, I am getting a maximum current. If I improve VG is equal to positive, means I can able to improve, so that I will get more current from drain to source. Okay, and so this is for I am giving a gate voltage -1. So on the time you can able to observe already a huge depletion layer are there. If I given -2, and it will become very higher, so path will be reduced, current will be reduced. Okay, so that is the condition. Just take characteristics here. Again they are telling about this. Look at this, Vg is equal to 0, I am getting maximum, and if I am giving Vg is equal to -1, by increasing the drain to source, the current become reduced. So this region is ohmic region, and the constant current where it is flowing, those are a saturation region. Okay, and if I keep on decreasing the gate voltage towards negative, I mean minus Vg is equal to -4 or Vg is equal to -5, so on the time it won't conduct. And you have to keep in mind that what will be a breakdown situation. So we should not exit the breakdown situation. If it is exit, I mean breakdown occur means again the current flow will increase rapidly. So we can able to probably damage the Jfet also due to breakdown. And Zener are specially designed to work in breakdown only, but PN junction is not. Due to avalanche breakdown, sometimes it may work, sometimes it may damage. So similarly, JFET also, we should not give the maximum voltage. That will be rated on JFET data sheet. So how much current it will make, what is the maximum voltage you have to give, everything will be mentioned. It's about P channel, and it's quite opposite my P channel. So N channel, what you seen, quite opposite here. So here the voltage and all it will be reversed. If you look at here, um, the gate should be in positive. Okay, here there you are making a negative, but here it will, you have to make a positive. So that is a difference. So between the N channel and P channel, and this is they are representing the breakdown region. I told you, right? If up to 15 the transistor will work fine. If you exit, I mean sorry, it's around 18, up to 18 the transistor will work fine. If it keep on increase means breakdown occur. Once breakdown occur in the sense the current is increasing maximum. So this is your breakdown region. And look at this, this is a p-type characteristics. So Vg is equal to 0 means maximum current, Vg is equal to positive means it is reducing, and if you give more positive it becomes more, I mean the current is become decreased. But if you look at that the N channel, if I'm giving negative voltage it become decreases, but in a P channel if I'm giving a positive means it become decreases. So quite opposite to your N channel. So this is the characteristics for a N channel, again it is showing, and this is for P channel. So they are just comparing. So 0, -1, -2, -3 negative voltage I am giving for a N channel, and a positive voltage +1, +2, +3 positive voltage I am giving for a P channel. Okay, so after this today we can wind up, and tomorrow we will see the remaining. Guys, any queries?
No, sir.
Okay.
Sir, mark the attendance, sir.
Yeah. Today only 17. Abhinav is absent. Abhinav, yes, and Basil and Emmanuel and Veeramanikandan. So 4 people absent. What
Okay,
happened?
sir. I don't know, sir.
Okay,
Nobody
Abhinav,
can inform me.
Abhinav and Basil and Emmanuel and Veeramanikandan. And Vikash and Sudeep are default na.
Yes, sir.
I don't know. Sure. Okay. So remaining all present ma. So Abhinav V present and Aditya present, Anantu present, Arun Kumar, Ashwin, Azad and Jodish, Sevaga Perumal, Louis and Madhuban and Namala, Nitin, Nitish, Sriraj, Syed, Uday and Vinith. Did I miss anyone? Okay. It's okay ma. Thank you. You can wind up. Thank you all.
Thank you, sir.